Welcome to GWA Physics, and this video is going to talk about a problem that deals with the work energy theorem. The example we want to use today is of a little boy who's going to climb up the ladder and ride the slide. And one of the things that we know is that the work done by the boy to climb the ladder is going to be equal to the change in his energy, because that's exactly what the work energy theorem states. It says that the work done on an object is equal to the change in their energy. So first of all, let's talk about what the work is. The work is going to be equal to the force applied times the distance that it's going to be carried out. And we all know that in order for this little boy to climb that ladder, he's either going to have to push with his feet or pull with his arms or both to lift his weight up the ladder till he sits down on the slide. So if we work this out, 30 kilograms, as you remember, is not a weight, it's a mass. So the force applied has to be 300 newtons, or the little boy's weight. And he's going to raise that a distance of 3 meters. And so the work done is going to be 900 Newton meters. Now, that would be the work done by the boy. Now, if we look at it from an energy standpoint, a potential energy is equal to mgh, where m is the mass, which is 30, and g is the acceleration of gravity, which is 10, but the height here at the ground level is 0. So 30 times 10 times 0 is just going to be 0 joules of energy. But then up here, that same mgh is going to be 30 kilograms times 10 meters per second squared times 3 meters, or that would be equal to 900 joules of potential energy. So, as we said earlier, the work energy theorem says the work done is equal to the change in energy. So we went from having 0 joules of energy to having 900 joules of energy as a result of raising the boy up 3 meters. And you can see that the 900 joules here is going to be equal to the 900 Newton meters of work that was done by the boy. And so the work energy theorem stands correct in that 900 Newton meters, and we need to understand that Newton meters and joules are the same thing. And so 900 Newton meters of work is equal to the change of 900 joules of energy as the boy climbs the ladder. Now, once this boy has this 900 joules of potential energy, one of the things that we also said in class was that 900 joules of potential energy at the top will be equal to the 900 joules of kinetic energy at the bottom. And where that comes in is the law of conservation of energy, in that the 900 joules here is going to be converted into kinetic energy as the boy slides down the slide. And that's the whole reason why we slide the slide, is that we have no motion at the top, but what we're counting on is that we're going to go sliding down the slide, and we will be at our maximum speed when we get to the bottom, which is the fun part of sliding on the slide. So now, if we have 900 joules of kinetic energy, then one of the questions that we might have to answer is, what is the velocity of the boy at the bottom of the slide. Now we can work that very quickly. 900 joules of kinetic energy is equal to 1/2 mv squared. And so we substitute in the 30 right here for the boy's mass. And so we've got 900 divided by half of 30, which is 15. And that's going to give us v squared. Let me grab my calculator right quick. 900 divided by 15 equals 60. Okay, so 60 is equal to v squared. So we're going to take the square root of 60 to solve for v, and we're going to get 7.75 meters per second. So he's got a pretty good velocity, assuming that there's no friction on the slide. Now, if you have any questions, see me about it, but thank you for watching the video.